Welcome to our lecture number 3. We want to discuss about construction of sectional views. These sectional views are very important because they show very clearly the details about the shape of the objects. And this sectional views is a continuation of orthographic projection and isometric projection. Now for this section of views, we want to clarify the details of a drawing, to illustrate internal features very clearly, also to facilitate the dimensioning of the internal features. It also reduces the number of hidden lines. We use it to show the shape of the cross section of the parts. Also, we show very clearly the relative positions for the parts forming an assembly. Why do we use sectional drawings? As we have said, sections are used to clarify the interior construction of a part that cannot be clearly described by hidden lines in the exterior views. When we see objects externally, we can hardly see, or we cannot see very clearly where the lines for object. For example, we are having this object here. This is the case. We have this object. This object have got 3 holes. So if we wanted this hole to be specific with their respective sizes, we use a cutting plane, a line that indicates where the cutting removal of the object will be taken to the other part. The part that is very close to the observer is regarded as removed. So behind is left the part that is indicated with the arrows. This is an example of a front view for our object here, front view being indicated with the hatching lines. The hatching lines here, these lines are drawn at inclination of 45 degrees from horizontal. So here is a full section. Full section meaning that it indicates the entire object from this side to another side, and the line has been given on the plan view, and the sectioning has been elaborated or shown on the front view. So another example is provided here. We are having another object. So in order to show the internal features without use of hidden lines, as you can see, this object, we cannot see the size for the holes here, like this. I've got 2 holes for this object. We cannot see. We simply imagine the lines where they pass. So to be exactly sure with the size and shape, we have to have a cutting plane. So this is a cutting plane for our object in the plan view, and we show it using the front view. So for our front view, we can see very clearly the hole, the size of the hole, and we can even use dimensions to indicate the size of the respective hole. So the cut portion nearer the observer is removed, and the remaining portion is shown as a sectional view. So the imaginary cutting marks are represented by thin, equidistant hatching lines, as I have explained previously. Cutting plane in sectioning. So this line, which we term it cutting plane, is used to show where the object is being cut. It's regarded to be cut by assumption. It is represented on a drawing by a long thin chain line thickened at each change of the direction and at both ends. The direction of viewing is shown by arrows resting on the thick lines at both ends as shown below. These cutting planes should be denoted by capital letters. So here are the two types of the lines that we use for section views. One is used for long distances and the other one is used for short distances. This cutting plane line style, the one for longer distances have got the dashes which are longer than the one for short distances. The longer one is approximately, this dash, single dash is of 6 millimeters approximate, and the space in between is 1.5 millimeter. Whereas for the case of short distance, the dash is 3 meters, half of the longer one. So, but the space in between is equal to 1.5 as for the case of longer line. So positioning of sections. So when a cutting plane cuts a drawing along the front view, so the section is shown on the top view. And when a cutting plane cuts a drawing across the front view, the section is shown on the end view. When a cutting plane cuts a drawing along the top view, as you can see here, top view, then the section is shown on the front view. It's very important to note this. When a cutting plane cuts a drawing across the top view, so the section is shown on the end view. So let's see what is called multiple section views. It happens sometimes we have the views or more sections in one object. So multiple section views can be created on a single multi-view drawing. This example shows horizontal and profile section views. Note that each section view is labeled to correspond to its cutting plane line. Let's have a look here. So this object here, I've got two cutting planes. The first one is A to A, and the second is B to B cutting plane. For the single object, the significance is to show the interior part of the object when it's cut. Both are cutting on the plan view. So the section will be indicated on the front view, front view and end view. So you can see here the section AA with a cutting plane laid AA. So this is how one will indicate the section AA, because it has cut along this hole, but the taller part of the object is not touched, it's not cut, as you can see. So when we are referring to cutting plane BB, this is for BB, you can see where it has passed and it indicates this way. So hatching lines are placed there. That's how we can do it. Let's see the types of sections. The first that I have been describing or elaborating about is the full section. We would have a half section, aligned section, offset section, broken section, removed section, and a partial section. Points to note for a full section. When you're drawing a full section, you have to note this. When drawing a sectional view, one half of the object is imagined to have been removed, is regarded to have been removed. So the adjacent view should show the entire object. So even the hidden feature lines behind the section are omitted. They are not inclusive. They are not inclusive. When we use, we are drawing in a full section, we do not include the hidden features. So for full section, this is our object. Our object with several holes in it, 5 holes. So for the case of full section, this is our line for cutting plane, termed as AA. It has passed through 3 holes. This one, the other one, they are left there. But the significance was to show how this hole looks like. The shape of our holes now is clearly seen in comparison to the plan. With the sectional view, you can see the shape of the hole very clearly. So this is how the so-called full section view looks like. So our object is given in an isometric drawing. You can see how it looks. But the isometric gives our a good picture of the object. However, it can hardly show the internal features of the object. So to aid this, we need to have a section view, of which we can see the inner part or interior part of our object. So cutting plane line is indicated here. This is a cross-hatching lines. Part outline heavyweight line, so you can show clearly the boundary lines with the thick or object line. Full section views also can be of this nature, because this hole is not in a straight line with this one. So this line AA, for it requires to show how this hole looks like internally. So we have to change the direction and see how this one looks like. So this is a section for our object. So you can see the hatching lines are placed, but these holes are different. If you can see, this hole is quite different from this. Maybe this has got some threads in it. You can see this layer is present, center line, but this one is smaller than this one. So it was of great importance to have a section view to aid us to see exactly the interior part of this object. Yes, this lag has 2 cutting planes. The one in bluish and the other in yellowish, we can say in blue, and the other one in reddish. And the very thing to focus is how this part is connected or is joined here, and how it's placed. This is rather vertical, and this one could say is lying in horizontal. The flatness is on horizontal, this one is in vertical. So to indicate it very clearly, 2 cutting planes are laid for the same object, because these parts differ. So if you want to express or to elaborate it more, you need to have two cutting plane of a single object. So with the bluish, you can see the outcome here. You can see the outcome showing very clearly how this whole looks like, because the cutting plane was in this nature. For this part was rather in vertical, whereby for this part is in horizontal case, which indicates how this object looks like. As you can see here, yeah, this is different from this part here. So hatching of the section views, the surfaces shown in the section are usually hatched at 45 degrees, as I have said, at some well-defined angle which avoids clashing with visible outlines. Spacing between hatching lines should be at equidistant. Yeah, so they are laid at 45 just to differentiate with the other lines, such as object lines. Here is an example of several materials that we normally use in our daily life for construction. This is for cast or marble iron. You can see how the hatching lines look like. When it comes to sectioning, steel, how they are laid, so you can have a comparison. And when it comes to bronze, you can see full lines and the dashes. When it comes to rubber, this one can have the hatching lines. White metal, zinc, lead, barbite, and alloys, they are rather zigzag form, and the others sound. Yeah, section for thermal insulation, it looks like this. Very important here to note, for concrete, yeah, it's like sand here for concrete. Bigger stones and smaller ones, they are laid here just to represent the section for material concrete. And others, sand here, water, earth, rock, and many others. So this is given for reference. So hatching, adjacent component should be hatched in opposite directions. This indicates that if there are two materials that are joined together, so in hatching you need to indicate that one material will have inclination to the other direction, like this. Yes, if at all they are hatched, indicate that they are like this is 45 here, and this one 45 degrees here from horizontal. Yeah. So hatching lines for additional adjacent parts may be offset, or alternatively, spacing between the lines may be increased or reduced. This is another means to indicate that they differ very much. You can use different spaces, where the other one could be much smaller. Yeah, this will indicate that these two differ very much material. Let's see for half sections. We had been discussing about the full section. The views is made by passing the cutting plane halfway through an object and remove a quarter of it. So a quarter is removed. A half section exposes the interior of one half of one object while retaining the exterior of the other half. Also, a half section is one half of a full section. A half section is one half of a full section, or a quarter of the object is cut. Two cutting plane lines at right angles a half of the view is represented by a cutting plane. So use it when drawing symmetrical object. Let's see. Points to note when sectioning half section. A solid line should be used to separate the sectioned half from the external half, but a center line is also acceptable if it happens that you use the center line. Also, the location of the cutting plane is shown in the view adjacent to the sectional view. So you see one example for half section view. Cutting plane here, you can see the cutting plane with an arrow this side here. So this part is like a quarter of the object. This is our object. Now we have a cutting plane, just a quarter of it. We have said half will be presented. Half, it was supposed to pass through up to this side. That would be the full section. But being the half section, it has to go this direction. As you can see, the result here, it simply indicates just this part of the object here, hatching lines. So you only work on this. Why? There is a repetition. Why repetition? So this method is rather economical instead of shading again there, because it resembles this side, resembles to this one. So no need of continuing doing the same thing to this. So you would say simply indicate this part here, as you can see here. We said this is used also for symmetrical object. This is symmetrical object. Let's see another method, which is aligned section. Another type. This is aligned section. With this aligned section is a section view that is drawn by imaginary rotating the object's features appeared in a principal view about symmetry axis. You have to imagine that is rotating and the features appeared in the principal view about the symmetry. So this example, we are given a rib. A rib is provided. Yeah. This is a rib of which I've got 3 supporting parts. You support the standing cylinder for this base. For the base here, some plates have been welded to strengthen the standing cylindrical part of it. It's like a wheel. So this part undergoes a so-called aligned section. So in the aligned section, you simply indicate this thickness of the layer without touching this part of it here. This is not indicated. However, the cutting plane passes through this, then comes at this point. But this, because is a supporting material to the standing cylinder of this part, we do not indicate the hatching lines. That's why you can see here. You should be aware of this nature of the material placed here for the purpose of supporting the standing material. So the thickness of this from the center hole is indicated here. Thickness of this material, and this through hole is a through hole, you can see. So this is a case of example for a rib. Aligned section. Aligned section. That was the aligned section. Features are removed to projection plane and then projected over. See here, This is the cutting plane here, aligned section. So this one indicates that a cutting plane passes there. To indicate this very clearly, this hole. So this object have a center here and a hole here. So it has been aligned. However, here it resembles, it appears as if it is at a certain angle, but when it comes for, it is on the end view, but the front view of it looks like this. This is the case of front view, and this is the case of end view of it. Or this is being the front view, and this is the end view. It does the opposite. The offset sections. In the sectioning through an irregular object, it is often desirable to show features that do not lie in a straight line. By offsetting or bending, it's very important to note here, offsetting, it employs bending of the cutting plane to search for the objects that are not in a straight line. Such a section is called an offset section. So this offset section is produced by bending the cutting plane to show features that do not lie in the same line, as I've said above. So the offset section, I have an example here. The cutting plane is given on the plan view. This hole is not in line with these two holes here. They are not in line. So a line for cutting plane has to change the direction here with thick line here, thick line, just to indicate that it has changed direction. Arrows are provided. So this is a plan view, and the section is given the front view. Front view indicates how these all are produced. You can see this is the center for the part here, center. This is a curve. Yes. We need to talk also about conventional breaks and the sections. Conventional breaks and sections. So conventional for round solid material. The taller material would like this. If you happen to break at the middle, if the material is very long, you would need in order to indicate in full. So if you want to break round solid, this is solid material. Solid material. For solid material, what do we do? At this part here, we have to use hatching lines here, which is different from round tubular material. Tubular material, what do? You have to include at the center some elliptical shape. At the center, it's like elliptical shape. Then you shade the left part, just a little part of it, you can shade. What matters just to indicate that this is a tubular material. Also, you can have a section. This has been to indicate how you can break it. So to section it, you break first, then you indicate the layer from the center for the tubular one. This is how one can indicate how it looks like for the this thickness of the material left after you have the hole. So lastly, for standard conventional breaks lines, rectangular cross section for wooden material, one would have the zigzag of Z nature to indicate that there is a breaking of the material. Also for metal, because metal are very brittle here, you can see how they are broken. And the cylindrical cross section, as we have said for the upper part, this is for solid one. For solid, we indicate it this way. Also for tubular, you will indicate it having some kind of elliptical shape inside, elliptical hole inside, and the shade is outside on this.